All right. What we're going to be taking a look at are some piecewise functions in this video, and something that we need to know or we need to have on hand here, if you can decipher it from what we got going on in this kind of cryptic looking title here, is that you're going to need a pencil for this one, and so you want to get one right now before it's too late. And as a piecewise function, as you look at it, we go ahead and we have the Mr. Potato person there, and they are all in pieces, and they are put together in this particular way. Now, it doesn't look right, but at the same point, it's pieced together, and it forms a more complete statement. And that's kind of what piecewise functions are. So what we're going to be doing here is that by the end of this lesson, we're going to be able to answer the following questions. It says, well, what is a piecewise function? How do I read the layout to two piecewise functions? And let's see, how can a real-world scenario be modeled through and this is a piece, it's supposed to be piecewise. I don't know what happened there. Oof. Piecewise function. And yeah, we'll be taking a look at that in other parts of the lesson as it comes up. So here we go. First thing that we want to look at is this business of the piecewise function itself. So it's going to have like a y or an output notation here. This is f of x, and then we're going to have a bracket, and then any number of functions right here. Okay, and the functions are going to be defined over certain parameters. Okay, and what we're going to go ahead and do is that we're going to be graphing the functions and then limiting them to their parameters and making sure that the parameters are defined at the very beginnings and ends, if need be, by a certain open or closed dot. So let's go ahead and take a look at this first one right here and do one out just to make sure that we are all clear what we're going to be doing. So the first one, what we want to go ahead and do is that we want to treat this just as we would graphing a line. So that is negative 2x plus 1. So I'm going to start this and then go down to over 1, go down to over 1, and then I'm going to go ahead and draw a line. Okay, just like that. And it's important that when you're graphing these out that you graph them in the using the entire graph. That is that you just don't do a little tiny bit. Okay, so what you want to do then is that we look at the parameter next, and the parameter says that this function lives where x is less than 2. So I look at where x is 2 right here, and so that means is that everything less than 2 is good, and everything greater than 2 is going to go ahead and not be legal, okay, because it doesn't live there. So what we're going to do is that I'm going to erase out everything, okay, that is going to be greater than 2. Now, what we have to do is also finish that out, because we cut the function there, and so we need to pay attention also to this sign right here. And so if it's a less than or greater than sign with no little equal sign, but pardon me, beneath it, then that means it's an open interval, and therefore it's going to get an open dot, just like that. Notice that I have an open dot here, and I have a arrow that is showing that that is going to be going towards infinity, and then it goes all the way back to this dot right here and stops. Okay. So the next thing that we want to do is that we want to grab our pencil, and I'm going to take a look at graphing this out. Okay, so graphing this as a line, I start at 3, and the slope is 1 in front of the x, so I go up 1 and over 1, right? And I'm going to draw my line through there like that. Okay, and what I have to do is I have to erase part of it as well, because this one says that it only lives where x is going to be greater than 2. Well, I found where x is 2, and this function only lives when x is going to go ahead and be greater than or equal to 2. So therefore, all of this stuff for the red line can go away. So let's make that go away. Okay. And so there's the 2. Oops, I almost erased too much. Haha. And I'm just going to leave that. We won't pretend like that little red dot's not there. And I erase this out, and I have to also take a look at, okay, well, I have this part right here. Pardon me. This is going to be a greater than or equal to sign. And so this is a greater than greater than or equal to sign right here. That means it's going to end on a closed dot. And so it's going to go ahead and go right here. And that arrow will go on into infinity, just like that. Okay. So that is an example of what the piecewise functions are going to look like. Now, those are just 2 lines, and what we're going to do is that we've been studying different functions here, and we're going to do them out based on some of those new functions that we've learned. Okay. So let's go ahead and see where that takes us. Okay. But before we do that, let's take a look at some functions that we might go ahead and be, these are some of the ones that we've been learning here, and want to make sure that we're just up to snuff with them and review. Remember that if f of x equals c, and say that c was 3 there, that it would just go ahead and be a straight line, and I shouldn't say a straight line, it should be a horizontal line, and this is going to be 0c, where c could be, in this case, it would be like f of x, that it would be equal to 3, where I put it. But at the same point, it could be any number. If it were a -2, then it would start down here and go down here and whatnot. Okay. So, but that said, is that we have to be pretty good with recognizing horizontal lines. We also have this business of just our regular straight line, right? Being able to graph those. I said straight line again, darn it. Our line that is just going to be defined by x, and that's a diagonal line that just goes ahead, and if x is 1, then y is 1. If x is 2, y is 2. If x is 3, then y is 3, etc., etc. Okay. And then we have our parabola that we've learned in math 2. Took a long time flushing all that out and whatnot. And our parabola looks like this. Okay. And, oops, it's kind of a sloppy parabola. It's a little bit better. Okay. And then we have our cubic function. And our cubic function is a little bit off the grid here. And again, we studied that, I believe, right in the last section here. And it looks like that. We have our absolute value. Okay. And with these piecewise functions, you want to be as accurate as possible right now. And we're going to get more accurate. I'm just kind of jogging our memory of what these things look like here. And then our square root function. It goes like that. Okay. So let's go ahead and apply these for this business of putting them into our piecewise function stuff. All right, and so here is our first example that is going to have a quadratic and a linear that we're going to go ahead and have to do out. And just like in the first example that we did, we're going to graph. Okay, so the 3 steps is that we're going to sketch the graph in pencil. Then we're going to cut the part that is not defined by the parameters, and then place a cap at the end of it, which basically means is that it is going to have either an open or a closed dot. And I'm just going to put on there real quick is that this and this are closed dots, and this are going to be open dots. Okay, so let's start by graphing the first one. Okay, and the first one right here, when I say that, is going to be this x squared. So this is part of the sketch phase. And so what we're looking at is sketching that graph out. Okay, and sketching the graph starts at, since we're going to do parent, multiplier, and shift, so we start with the parent function. It's a parabola. Okay, like that. And we notice that it has inside there, right, inside the parentheses, it's going to tell us to go the opposite direction 2. So we're going to go left 2, like that. So all of those dots are going to go left 2. And so I'm going to go and shift these all on over. Make it nice and clean looking. Because you want these graphs to be as accurate as possible because you're looking at places eventually where the graphs are going to meet. And once you're done also, you want to get rid of the old stuff just so your graph is not all cluttery. Okay, so we've done the sketch. Now we want to cut. Okay, and this says everything that is less than or equal to a -1 is going to go ahead and stay, and everything greater than has to be erased out. So let's do that. Okay, so we go ahead and go right there, and then we pay special attention to this sign, and the sign is going to be let's see, less than or equal to. Less than or equal to is a solid dot, and so, or a closed dot, and I'm going to put that, oops, I guess you want to do it in highlighter, I guess that works. And there's my first graph. Okay, so again, I did it by sketching, cutting, and then capping. All right, so let's go ahead and take a look at this business of the next one. And the next one is going to be that linear function. It's a -x minus 3. And so I have this minus 3. Okay, and that's where I start. And then I go down 1 over 1, down 1 over 1. Okay, and graph like we do with lines. So here we go. So we got this business of going through here. All right, so trying to go ahead and make that as nice as possible. Okay, so that said is that we start again at a -3. And then we go down 1 over 1 because of the slope. And that means is that our sketch part is all done. That's a regular y equals mx plus b line. And then we're going to cut it. Okay, so this says it exists where x is greater than a -1. Here's a -1. So all this is good. All this stuff not so much. So we want to cut that out of there. Okay, so we erase it all the way up to a -1. And then we see that, place a cap at the end of it, that we need to go ahead and it's just a less than sign. So we're going to go the less than sign, which is going to go ahead and be an open dot, okay, because of these guys right here. Oops, iPad stuck a little bit. And so I'm going to do an open dot right there, and there's my graph, okay. Now, we're going to ask some other questions in regards to these. And the first question that we could ask once it's all done, because we're all done with the graph, we sketched both of them, we cut both of them, and capped both of them. And so this is what the graph looks like. It's kind of peculiar looking, but is what it is. And this is going to be, is the graph continuous? Well, the graph's not continuous because there's going to be a break in the graph. That means is that going from this point to this point, right at that -1, if the graphs were connected here or here, then it would be continuous, but not so much. There's a break in the graph. And so it's going to be no. There's a break in the graph. Okay. And so that's going to be real important for us moving forward to understand. Another thing that we want to go ahead and do is being able to evaluate at a point, okay? So evaluate this function at a point. So the way that we're going to do that is the following, is that we see where we have f of a -3. So what we're going to do is that we're going to plug a -3 in here, and we're going to have to determine, okay, is a -3 less than or equal to a -1, or is it greater than a -1? So I think we know that f of, or a -3 is going to be less than or equal to a -1. So we'd plug it into this equation, okay, because that's the parameter that it fits. And so to do that, we would plug it on in. And so I'm going to go the -3, and then we go plus 2 squared. And that at the end of the day is going to give me a -1 squared, which is 1. Okay, and we can see that the point right here, -3, 1, is correctly graphed. Okay, now we also have this guy right here, and this is where it kind of gets tricky. It's where the less than or equal sign is going to come into play, is that if we have a -1. So if I plugged a -1, is a -1 less than or equal to a -1, or is it greater than a -1? Well, that's where that equal sign in the bottom comes into play, because it's going to be a -1 is going to be equal to a -1. And so therefore we'd plug it into this guy again. And so it would look like this. So we'd have our -1 plus 2 squared, okay? And that's going to give us a +1 squared, and that's going to give us 1. And you can see that, again, 1, 1 right here is defined on our graph. And next we have a +1. And so a +1, I think you can see where this is going, is that the +1 is going to be greater than a -1. So therefore, I will go ahead and plug it on in to the second graph, okay, this time. And so I'd go negative, and then I just throw in 1 right there, making sure that I always put my parentheses. And so that's going to give me -4. And we can see that that point right there, 1, -4, is on my graph, so it's all good. Okay, so that's how we do those. And we're going to be moving on to these next examples, where I'm going to have you guys graph them, and then we're going to be checking our answers together with them and seeing where that takes us. So see you in the next example. All right, in these next examples, I'm going to go ahead and I'm not going to be showing all the steps in graphing per se. I'm going to be showing all the steps in this part right here. But the graphing is a review from the previous lesson, so we'll go ahead and we will just go under the assumption that that is under control and you guys understand that. Okay. If not, then you might have to go ahead and look back at the next lesson, or the previous lesson about the parent multiplier and shift. Okay. So first thing that we want to do is that we want to graph this guy. So I'm going to go ahead and put that graph on the graph to the right, because that's part of our first step, which is sketch. All right, so that's what that looks like graphed out. And we have, it exists when it is greater or equal to 4. Okay, so there's 4. So everything from this side is going to go ahead and be good. So this side needs to be erased. So I'm going to get all that out of there. And then the cap is going to be a solid dot, because we have a greater than or equal to sign that we can go ahead and see right here. And then we put this right here. And that's our graph. Strange looking thing, but kind of is what it is. Okay, so is the graph continuous? And the answer is no, because you can see that there is a break right here. And so it is not continuous. Okay, and then we're evaluating the points here. And so what I'm going to go ahead and do is I'll walk you through that. Is that -3 -3 is going to be less than 4. So therefore, we're going to go ahead and get, okay, when we plug it on in, we're going to get 6. And you can see that that matches up right here. Okay, so we got 3, 6. So that's good news. And then we got this business of a 4. So 4 is going to be equal to 4. So we'll plug it into this. And we're going to get, okay, looks like we're getting 2. Oh, -2. Sorry about that. So we're going to get a -2 because I forgot that negative to bring it down. So, yep, here we go. -2 over here. All right, so 4, -2. And then this one's way off the graph, but remember that this goes to infinity over here. And so therefore, it keeps going. So we can easily evaluate something that's off the graph. Doesn't have to be within that little grid right there. And so what we're going to do is that we're going to take that 100, and 100 is greater than 4. I'm going to plug it on in, and so we get -10. Okay. So that's how you would do that one. And let's do another example and together. So I'll meet you there. Okay, so this one has some trickery with it. And so let's go ahead and start like we have been. And let's graph this one first. Okay, and then we'll do the cutting and capping. So let's knock that out. All right. So there we go. It's a parabola facing down, looks like that. And we notice that our restriction here is going to be when x is less than 0. Okay, that's where it's defined. And so all of this is good, but this part is not. So we need to get rid of that. And then we're going to go ahead and check that that sign. It is less than. Okay, so less than sign. So when we cap that, it is just going to be an open dot like this. All right, so let's graph this next part, which is right here. Okay, so this graph goes ahead and looks pretty interesting here. Is that it is going to go ahead and let's take a look. That blue graph is already intersecting with the red one right here. However, we just need it to be defined where it is greater than 0. Which is right there. So this blue part right here can be erased away. Okay, and I also want to bring up is that you notice that it ends right here on the same dot. And we had before, the red had an open dot, and then the blue had a closed dot on the same spot. So if we had something like, if you look down below, that open dot and then something end on there, then the fill in is always going to win. So that counts as a filled in dot right there. Okay. So therefore, if we ask, is this continuous? We say yes. There are no breaks in the graph. Okay. So, that is going to go ahead and basically answer up through here. And then we got this business of shifting this graph. Now, I just want to make sure that you guys know is that all of these graphs can be shifted. So that said, is that I'm going to go ahead and just real quickly show you guys what this would look like if you shifted the graph. Now, I'm going to keep this, this picture as is, and then I will show you what this graph right here will look like if it's shifted. Now notice it says right here we can shift that entire graph in the opposite direction, right? Because it's in here. So we would go left 4. So what that would look like if I shifted the graph that we did just a moment ago, it would look like this. Okay, so it would look like this business of all those points would be going to the left 4. Okay, so that's a legal move. So the whole graph is going left 4. All right, and so we can shift after we do a piecewise function. The other one that is going to go ahead, we'll take a look at is this guy, and we could do a reflection and a bunch of other shifts. So let's go ahead and see what that looks like as well. Okay, so this time it would be, I reflected it over the x-axis, and I moved it right 3 and down 1, and that was my new graph. So all the same rules apply to a piecewise function as a regular function. Okay, So our final example, we're going to take a look at what happens when there's more than just two pieces in the piecewise function and see what happens there. Okay, so we have a piecewise function here with three parts, and I'm going to graph this first one first, okay? And the same, everything is going to apply. So what I'm going to do is that I'm going to graph 2x minus 3, so I do sketch mode. Okay, so it's sketched, and it only exists where x is going to be less than 1, okay? So where x is less than 1, here's 1. So everything here stays, everything to the right of that has to go. And so I'm going to get rid of that, less than 1. Okay, and then I notice it has a less than sign, and so therefore it is going to have an open dot. Okay, now here is something that's rather new, is that this is going to go ahead and be like that constant, that horizontal line. Okay, and so what we have is that the horizontal line, this is similar to saying y equals a -1, because technically it's y, or f of x, equals a -1. So what we do is that we just do our regular horizontal line through there like that. Okay. And in this case, we have something that's brand new. It says that x is going to exist in between 1 and 4. Okay. So that means is that it's going to be existing in between 1 and 4, and that's it. So everything greater than 4 is cut off. Everything less than 1 is cut off as well. So let's clean that up like that and on over. And you notice that we have another situation where we have a filled in dot going on top of a an open dot. So it goes like this. Oops, that's the highlighter. And over to 4 right here. And then finally, so that finishes up that guy. That was like a double cut, because we had to go ahead and say closed dot right here and a closed dot right here. So now we've got to graph the next one, which is going to be this color right here. I'll just make it black. It's easier to see. So graphing that out, okay, we have this y equals mx plus b form. And so this one says right here, where x is greater than 4, that's where that guy lives. So, whoops, I erased that out. That was, so x greater than 4. So all of this is good, and all of this needs to go away. So let's do that. And notice that the blue line still has the priority here, even though that this is going to be right here. If we look at the, and that's going to be an open, but it's closed in right here. So it's all filled in. So since it's all filled in like that, and it's supposed to be an arrow right there, is that we can see that this is going to be a continuous graph, okay? And that there's no breaks. Okay, so if we were to go ahead and evaluate these out, I'm going to evaluate these out for you and see if you get the correct answer, okay? And so I'm going to start plugging in these points right here at the evaluating points. All right, so the first one is going to go ahead and look like a -203, right? So we got a -203. Now, you might have got stumped with these two right here, because you notice that the 2 and the 3, they are going to fall in between the 1 and the 4 right here. So anytime that you're plugging a number in that just has a constant, you're just going to get that constant out, okay? So for example, I know that if I plug a 2 in, that's going to give me a -1 out, because it's in between 1 and a 4. And so is a 3, because that's in between 1 and a 4. And if we look at the graph, right, that makes sense, because that's where they are. That's what a constant does, okay? It's not going to go ahead and change the y value whatsoever, no matter what you plug in for the x value. So that is an overview how to do piecewise functions. Hope that was helpful for you, and I will see you in the next lesson.